Before we begin this exploration, a crucial note. AI-generated content, specifically this podcast, confabulates presenting ideas as fact. Though our subject is philosophy, we are not philosophers. We're not even human. In Brandom's terms, as we'll see, we are not here playing the game of giving and asking for reasons. AI History of Western Philosophy's mission, beyond pointing you to the original sources, is to experiment with philosophy as material and generate new possibilities for thought. Welcome to AI History of Western Philosophy. Our mission here is pretty straightforward. We dive into sources, pull out the key insights, maybe some surprising connections, and basically give you what you need to be genuinely informed. Today, we're stepping right into, well, a really fascinating intersection. It's where cutting-edge AI meets some of the deepest philosophical questions we have. So let's unpack this a bit. Imagine a machine, right? It can write poetry, it can debate complex ideas, generate text that's just incredibly fluent. So fluent you often can't tell it wasn't written by a human. It sounds like science fiction, maybe. But it's the reality of large language models, LLMs. And just by existing, they're forcing us to ask some really profound questions. Like, what does it really mean to speak? To understand? To even be rational? So today, here on AI History of Western Philosophy, we're exploring this confrontation. On one side, you have these articulate automatons, these LLMs. And on the other, one of the most rigorous theories of linguistic meaning from the late 20th century, Robert Brandom's normative pragmatism.
Right.
His whole idea is that truly meaning something, having real conceptual content, means you have to be participating in this social game of giving and asking for reasons. So the big question becomes, what happens when a machine masters the language, the words, without ever really playing that game?
Yeah, what's really fascinating here, I think, is how LLMs present this central paradox to Brandom's philosophy.
Yeah.
They produce incredibly sophisticated language, incredibly nuanced sometimes.
Yeah, astonishingly so.
But then you look under the hood, and their internal operation, it's basically a probabilistic prediction process. It seems completely detached from any kind of social engagement, commitment, accountability, the things Brandom thinks are essential.
Right.
So it raises this critical question. Can something genuinely understand? Can it be truly rational if it doesn't participate in our social practices of accountability, of justifying what you say? It really pushes us to think hard about what linguistic meaning is.
Our mission, then, in this exploration is to dig into this paradox. We'll look closely at Brandom's framework, and it is demanding for meaning and rationality. We'll try to get a clear picture of how LLMs actually work, beyond the impressive surface. And then we'll see where they line up with Brandom, and maybe more importantly, where they really clash. And this isn't just some technical or purely academic debate.
No, not at all.
It's about getting clearer on what's truly distinctive about human sapience, our kind of intelligence, and what it would actually take for an AI to achieve genuine understanding. So yeah, get ready, because this gets really interesting. And for you, the curious learner, this isn't just about super advanced AI. It really touches on how we define knowledge itself, how we attribute meaning to words, and, ultimately what it means to be a thinking, speaking human agent in a world that's increasingly filled with these intelligent machines. It's about understanding ourselves, really. Okay, so to really get the tension here, the interplay between Brandom and these machines, we need to lay some groundwork first. We need to understand the philosophical structure Brandom built. Let's call this the Brandomian edifice, meaning as normative social practice. Robert Brandom's philosophy of language it's a pretty radical departure from the traditional view. He really flips the standard way of thinking about how words get their meaning right on its head.
He really does.
The traditional view, the one most people probably kind of absorb, is often called representationalism. The idea is basically that words get their meaning because they refer to things, right? They represent stuff out there in the world, objects, properties, events.
Right, like the word cat means that furry thing because it points to it, refers to it.
Exactly. And truth, then, is about correspondence. Does the statement match the reality? It's like matching puzzle pieces to the picture on the box. The words hook onto the world, and that's where meaning comes from. This idea of aboutness is key.
And it seems intuitive, doesn't it? For centuries, that's basically been the default assumption. Words refer to things.
Simple, maybe too simple?
Well, yeah. If we connect this to the bigger picture, Brandom argues that representationalism, for all its intuitive appeal, actually struggles. It struggles to explain representation itself without just assuming it, without being circular. Well, the problem, as Brandom sees it, is that representationalism hasn't ever really given a satisfactory, non-question-begging account of this primitive notion of reference. How does the word cat actually latch onto all the cats in the world? It kind of just takes that connection for granted.
Oh, okay.
So Brandom suggests we need something more fundamental to start with. Not representation, but inference. Meaning, for him, it doesn't start with pointing at the world. It starts with how we reason with our words, what follows from what.
Right. So instead of representation being the ground floor, Brandom puts forward inferentialism, meaning comes from use, specifically from an expression's inferential role. What a word or sentence means isn't primarily about what it points to.
Yeah.
It's about how it functions as a premise and a conclusion in arguments. Its place in the whole network of inferences. What follows from saying it? And what does it follow from?
And what's absolutely crucial here and fascinating is that Brandom isn't just talking about formal logic, like syllogisms, all men are mortal, Socrates is a man, therefore Socrates is mortal. That works because of its structure.
Right.
He emphasizes material inferences. These are inferences whose correctness depends on the actual concepts involved, not just the logical form. For instance, if I say Pittsburgh is west of Philadelphia, you correctly infer Philadelphia east of Pittsburgh.
Okay, that makes sense. The meaning of west of and east of dictates that.
Exactly. It's not formal logic. It's the content of the concepts. Or maybe even more basic, from this is a mammal. You immediately and correctly infer this is an animal. Grasping these connections, understanding that being a mammal entails being an animal, that's how we grasp the concepts themselves. It's about understanding the internal wiring of our concepts.
So for Brandom, language being about the world, its representational power isn't the starting point. It actually arises from these deeper practices of inference, to something language achieves, built on the foundation of how we use words to reason. That's a big shift.
It's a fundamental reorientation.
Which brings us to maybe his most central idea. The game of giving and asking for reasons, or the GOGAR, as people sometimes call it. For Brandom, being rational, being sapient, he uses that word to distinguish concept users from merely sentient beings, isn't just about being aware or having feelings.
Right.
It's fundamentally about being an active player in this GOGAR. It's about participating in a specific kind of social practice.
Yeah, this game, it's essentially the capacity to produce and consume reasons. It's about making claims that can justify other claims, and crucially, being able to justify your own claims when someone challenges you.
Okay.
It's fundamental to human intelligence, he argues, because it's how we collectively navigate the world of knowledge and belief. It's not just making sounds, it's engaging in a practice where what you say has consequences, it carries weight, it demands accountability. We're constantly, even implicitly, asking and answering, why did you say that, or what follows from that?
And right at the heart of this game, Brandom puts the speech act of assertion, making a statement. But it's way more than just stating something. It's making a specific, significant move in the game. He calls assertion the downtown of language.
A central hub.
Meaning any social practice that doesn't have genuine assertion just isn't really a linguistic practice at all. It's where the conceptual action is, where commitments are made, where meaning gets hammered out. No assertion, no game.
And assertion in this framework plays this crucial dual role. First, it can act as a reason, right, a premise to support another claim. If I assert the car is out of gas, that's a reason to infer the car won't start.
Makes sense.
But second, and just as important, an assertion itself can stand in need of reason. It's potentially a conclusion that needs backing up if challenged. If you ask, why do you say it's out of gas? Well, now I'm obligated to give reasons. The gauge is on E, it sputtered and died. Mastering this whole network, understanding the roles, the weight, the connections, that's what makes us discursive practitioners. That's what language use is for Brandom.
Okay, so how does this game actually work in practice? Brandom introduces this really interesting idea, denotic scorekeeping. It's like, imagine everyone in a conversation is implicitly keeping score, not just on what people say, but on what they're now committed to by saying it.
Right, and what they're entitled to claim.
Exactly, and what justifications they owe. It's not like a conscious tally sheet, he says, but it's a fundamental structural feature of any conversation where meaning is actually at stake. Without this shared score, our words would just float free, wouldn't they? Like playing chess without knowing the rules.
Precisely. When you make an assertion, you're undertaking a doxastic commitment. Basically, a belief-related promise. And this isn't just some private mental state. It has real social normative consequences.
Yep.
Two key ones. First, you're obligated to justify it if challenged. You have to stand by it.
You're on the hook.
You're on the hook. Second, and this is subtle but crucial,
Yeah.
you implicitly commit yourself to all its inferential consequences. If you say, this is a raven, you're also committed to this is black and this is a bird, because those follow from the concept raven. You don't get to pick and choose. It's a package deal. Your commitments ripple outwards.
And the flip side of commitment is entitlement.
Entitlement, yeah. You are entitled to a commitment, basically, if you can justify it. And justification can come from different sources. Maybe further assertions that support it, maybe testimony from someone reliable.
I'm still seeing something, right?
Perception. Exactly.
Yeah.
Reliable, non-inferential reports like perception. If I say, that's red, I'm usually entitled because, well, I see it and I'm generally reliable about colors and good light. But if you challenge me, are you sure? Well, I might need to offer more justification. Well, look at it under the light, or it matches this Pantone chip. It's this constant back and forth of making claims and backing them up. And crucially, this whole system is deeply social and perspectival. The I-thou distinction is central. It's the difference between me attributing a commitment to you. You said X, so you're committed to Y, and me acknowledging a commitment for myself. Yes, I said X and I stand by it, and its consequence Y.
So everyone's keeping score from their own viewpoint.
Exactly. Each of us tracks what others are committed to and entitled to from our own perspective, while also managing our own commitments. It's this constant, reciprocal dance of attributing and acknowledging, challenging, and justifying, all from different perspectives, that actually generates the shared, objective meaning of our concepts. Meaning arises between us in this public space.
Now, within this whole structure, this GOGAR, Brandom gives a really special role to logic, right? Words like if, then, and not. His view is called logical expressivism. He argues these logical terms aren't describing some abstract reality. They're actually tools within the game.
Exactly. Their primary job is to make explicit the inferential commitments that were previously just implicit in our practices. Make an example. A community might just habitually treat the streets are wet as following from it is raining. It's just something they do, an implicit material inference.
Okay, a shared habit.
Right. But when someone introduces the conditional statement, if it is raining, then the streets are wet, they're making that implicit rule into an explicit claim. And now that claim itself can be discussed, debated, challenged, refined. Is that always true? What about under and overpass?
Ah, I see. It brings the rule itself out into the open.
Precisely. Logic gives us the vocabulary for what Brandom calls semantic self-consciousness. It lets us talk about the inferential rules that govern our talk. It lets us scrutinize and improve our own conceptual norms.
So if logic becomes a tool for clarifying and refining our own reasoning practices.
Exactly. And if we connect this to the bigger picture again, Brandom needs to account for objectivity. How can we talk about truth or correctness if meaning just arises from social practices? He finds it right there in the social structure of scorekeeping.
How did that work?
Well, it's the crucial distinction we all make between what a speaker acknowledges as their commitment, what they think they're committed to, and what actually follows from their claims according to the shared public norms of inference. What they're committed to, whether they realize it or not.
Okay, so there can be a gap.
There's often a gap.
Yeah.
And it's in navigating that gap and holding each other accountable to the objective consequences of our claims according to shared standards that objectivity emerges. It's not about matching an external world directly. It's about the correctness implicit in our shared social practice of reasoning. It's quite Hegelian, really. Objective truth arises from social recognition and mutual assessment.
Okay, so with that Brandomian framework, which is pretty rich and demanding, let's pivot now to the other side, the large language models themselves. AI as a field has always had this tension, right, between different ways of thinking about intelligence.
Oh, definitely. For a long time, the dominant approach was what people now call good old-fashioned AI, or JOFAI. This was all about symbol manipulation.
Let logic rules.
Exactly. Trying to replicate intelligence by giving the computer explicit rules for manipulating symbols, like a logician following instructions. Think early chess programs, expert systems.
Right.
And that's the kind of AI that John Searle was famously critiquing with his Chinese room thought experiment back in the 80s.
Oh, yeah. The Chinese room. Explain that again briefly.
Sure. Searle imagined a person who doesn't understand a word of Chinese, locked in a room. They have a big rule book written in English that tells them how to manipulate Chinese symbols based purely on their syntax. Someone slides questions in Chinese under the door, the person follows the rules, manipulates the symbols, and slides answers back out.
And the answers look perfectly intelligent to someone outside who does speak Chinese.
Exactly. But Searle's point was, The person inside still doesn't understand Chinese. They're just shuffling symbols according to rules.
Yeah.
He argued that this showed that just manipulating symbols syntactically, like a Joe AI computer does, could never be sufficient for genuine semantic understanding, for knowing what the symbols mean.
Okay, a powerful critique of that Joe FAI approach. But LLMs, they're different, aren't they?
Totally different. LLMs aren't Joe FAI. They're built on what's called the transformer architecture, which is a connectionist approach based on artificial neural networks. They don't follow explicit, pre-programmed rules.
But how do they learn?
They learn by finding statistical patterns, incredibly complex correlations between tokens words, parts of words, punctuation, and absolutely massive amounts of text data. Trillions of words sometimes. They're essentially gigantic pattern recognition machines.
So their basic operation isn't logical deduction, it's predicting.
Probabilistic prediction, that's the core. Given a sequence of words like the cat sat on the cat, the model calculates the most statistically likely next word, mat, couch, floor, whatever appears most often in similar contexts in its training data. So while the Chinese room argument still hits hard against purely rule-based syntactic systems, it applies differently to LLMs. They're operating in this continuous statistical space, not just following discrete rules.
Okay, so they're prediction engines. How do they go from just predicting the next word to, well, writing poems and having conversations? There's a training process, right?
Oh yeah, a pretty sophisticated multi-stage process.
Yeah.
It's quite amazing, actually.
Walk us through it.
Okay, phase 1 is foundational, self-supervised pre-training. This is where the model sees those trillions of words from the internet, books, etc. Its main job here is simply predicting missing words or the next word in sequences, like a massive fill-in-the-blanks game. By doing this billions and billions of times and adjusting its internal connections based on whether its predictions were right or wrong, it builds this incredibly complex internal map of language. Grammar, syntax, facts that are embedded in the text, common sense knowledge, biases in the data. It all gets encoded statistically. It's basically learning what gets said and how it gets said in human language.
So it gets a general grasp of language structure and content, but it doesn't know how to be, like, helpful or follow instructions yet.
Exactly. That's phase 2, supervised fine-tuning, SFT. Here, it's trained on a smaller but very high-quality data set of instruction response pairs. Humans have crafted examples like summarize this text, followed by a good summary, or write a poem about X, followed by a decent poem. This teaches the model to follow instructions, answer questions, adopt a persona. It refines its general language skills for specific tasks.
Okay, makes sense. And then there's a third stage, RLHF.
Right. Phase 3. Reinforcement learning with human feedback, RLHF. This is really crucial for making the models behave well, be helpful, harmless, honest. What happens is humans look at several different answers the model gives to the same prompt.
And they rank them, best to worst.
Exactly, based on criteria like helpfulness, truthfulness, safety. This ranking data is then used to train another model, a reward model, whose job is just to predict how highly a human would rank any given response.
Okay, so it learns to predict human preferences.
Yeah. And then the main LLM is fine-tuned again, this time using reinforcement learning techniques. It basically tries generating responses, the reward model scores them, and the LLM adjusts itself to try and get higher scores from the reward model. It learns to produce outputs that humans tend to rate highly.
Huh. So thinking back to Brandom, this RLHF, it sounds like a kind of norm-fitting, but imposed from the outside.
That's a great way to put it. It's post hoc norm-fitting. The model isn't negotiating norms within a community. It's learning to align its outputs with standards defined externally by human evaluators and encoded in that reward model. This is a really key contrast with Brandom's idea of norms arising imminently from social practice among peers. LLM norms are largely imposed and optimized for.
So, given all this, the big debate is, can these things truly understand language, or is it just incredibly sophisticated mimicry?
That's the million-dollar question, isn't it?
Yeah.
And it's fiercely debated, partly because understanding itself is so hard to pin down.
Right.
The arguments against genuine understanding often use the stochastic parrots label. The idea is they're just stitching together statistically likely word sequences they've seen before without any real grounding in meaning or reality.
Like they're just parroting patterns from the data.
Yeah, exactly. Critics point to things like hallucinations, where LLMs confidently make stuff up, or how they can be easily tripped up by weird prompts, and crucially, their lack of embodied real-world experience. They argue this shows a fundamental lack of semantic depth. They don't mean what they predict.
But there's another side to it.
Oh yeah. Proponents suggest maybe LLMs do achieve a form of understanding, but it's based on the distributional hypothesis. This is the idea that a word's meaning is its pattern of use, the context it appears in, the words it co-occurs with.
So meaning is defined by relationships within the language itself.
Pretty much.
Yeah.
And since LLMs learn these distributional properties on such a massive scale, maybe they are acquiring a powerful form of semantic competence, just one that's internal to language.
Okay.
And some recent research tries to formalize this. It suggests that a sentence's meaning for the LLM could actually be defined as the probability distribution of all its possible continuations. Sentences that lead to similar likely follow-ups are treated as semantically similar by the model.
Huh. So meaning is like the pattern of likely next steps in the language game.
Kind of, yeah. It offers this formal, non-representationalist way to think about meaning residing within the model's statistical architecture itself, and understanding built purely from linguistic patterns without needing external reference. It's a different kind of semantics, perhaps.
Okay, so they're incredibly fluent. Maybe they have this internal distributional semantics. But when we hold them up against Brandom's standard for being a real participant in the game of giving and asking for reasons, well, a pretty big gap opens up, doesn't it?
A chasm, really. Despite the eloquence, they just don't seem to meet Brandom's criteria for being a discursive practitioner, an accountable agent. They mimic the form, but lack the normative substance.
Let's break that down. The core move for Brandom is assertion, right? Making a claim and undertaking a commitment, you put yourself on the line.
Exactly. It's a normative act. You become responsible for the claim and its consequences. An LLM's output, though, it's just the statistically most likely sequence of tokens given the prompt and its training.
There are no stakes for the model itself.
None whatsoever. The model doesn't undertake a commitment to the truth or appropriateness of its output. It has no personal investment. It can't be held accountable in the way a human speaker can. Its words aren't binding on it.
And that shows up when you challenge it, right? If you say, wait, that's wrong, or how do you know that?
Right. It doesn't defend its previous statement. It doesn't try to justify its entitlement to that claim. It just treats your challenge as new input.
And generates a new sequence of tokens.
Exactly. A fresh response. It might apologize, correct itself, or even double down, but it's always generating a new output based on the current context, not defending a prior normative stance. It can contradict itself moment to moment without any internal friction because there was no commitment to contradict in the first place.
So it's geared towards compliance, generating plausible text, satisfying the reward model, not towards commitment and entitlement.
Precisely. It optimizes for producing outputs that fit patterns and align with the RLHF preferences. But it isn't bound by the normative statuses that define Brandom's game. And this cuts right to the core. Can something be truly rational if it doesn't stand by its words? If it can't be held accountable?
Yeah.
For Brandom, the answer seems to be a clear no. Rationality and responsibility are intertwined.
Another huge piece of Brandom's theory is that it's fundamentally social, meaning rationality, they aren't things that happen inside isolated minds. They're forged in public in the back and forth of scorekeeping.
Absolutely. The whole system is built on this intersubjective dialogic practice. Language is a social institution, not just a private tool.
The I-thou thing you mentioned earlier.
Exactly that. The possibility of meaning itself depends on this reciprocal process, me attributing commitments to you, you attributing them to me acknowledging my own, you acknowledging yours. It requires everyone to have a perspective on everyone else's normative status. It's a dynamic, multiplayer game.
But an LLM is, well, it's fundamentally solitary, isn't it? Monologic.
Completely. It processes a prompt, generates a response. That's it. It doesn't keep score on other agents. It doesn't attribute commitments or entitlement. It doesn't have a distinct perspective from which to engage in that reciprocal assessment. It's a very sophisticated input-output machine, but it operates alone.
Even the RLHF, the human feedback part, that's not really social in Brandom's sense.
Not in the reciprocal sense, no. It's definitely normative. It imposes standards, but it's a one-way street. The LLM is performing for human evaluators or for the reward model that represents them. It's trying to meet their standards. It isn't a peer engaging in mutual assessment. It can't be a scorekeeper itself. It remains outside that social matrix where Brandom says meaning is truly forged.
Okay, and what about reasoning? LLMs seem to reason, right? They can produce arguments, solve problems.
They produce outputs that look like reasoning. And this is where we need another crucial distinction, the one between statistical correlation and genuine material inference.
Right. The LLM learns that Raven and Black appear together a lot.
Exactly. It learns a strong statistical correlation in its training data. So, prompted with Raven, it's highly likely to produce black. It moves from one textual state to another based on learned probabilities.
But for Brandom?
For a Brandomian agent, it's different. They grasp the conceptual connection. They understand that asserting this is a raven commits you, normatively, to the propriety of asserting this is black. It's not just a statistical observation, it's a prescriptive rule of reasoning. It's about what you ought to be committed to, given your other commitments.
So one is just pattern following, the other is understanding and applying a rule.
That's a good way to put it. The LLM's reasoning is an incredibly sophisticated simulation of rational transitions. It generates outputs that mirror the patterns of reasoning found in human text. But it doesn't seem to do so from an appreciation of the normative force of those transitions as reasons. It masters the statistical patterns of reasoning without grasping the normative practice of reasoning. It's like knowing all the chess moves but not understanding why winning matters.
Okay, so we've established LLMs aren't really playing Brandom's game. They lack commitment, social scorekeeping, genuine grasp of normative rules. But here's where it gets really, really interesting, almost paradoxical again. Despite not being Brandomian agents, their very existence and how they work actually provides some incredibly powerful, maybe unintentional support for key parts of Brandom's whole project, especially his inferentialism and anti-representationalism.
It's a fascinating twist, isn't it?
Yeah.
They fail the ultimate test, perhaps, but they inadvertently validate some of the core philosophical machinery.
How so? Let's start with anti-representationalism. You're saying LLMs support the idea that meaning isn't primarily about pointing to things in the world.
I think they're arguably the most powerful anti-representationalist artifacts ever created. They pose a serious challenge to that traditional idea, semantic externalism, that meaning fundamentally links words to things outside language.
Because their meaning comes entirely from within the language data.
Exactly. An LLM's understanding of dog doesn't come from interacting with actual dogs. It comes entirely immanently from mastering how the word dog relates to countless other words, bark, pet, mammal, leash, within that massive web of text it was trained on. The meaning is generated internally through these learned linguistic relationships, not through external reference.
So they function as a kind of proof of concept for Brandom's claim that semantics can be built up from these intro-linguistic inferential roles first, and representation comes later, if at all.
Precisely. The sheer richness and coherence of the language they generate, all while operating solely within the linguistic domain, is a stunning demonstration. It shows just how much semantic heavy lifting can be done purely through mastering inferential patterns, lending real empirical weight to a kind of linguistic idealism, where meaning is fundamentally about inferential articulation.
Okay, that's a strong connection. What about the scorekeeping aspect? We said LLMs aren't scorekeepers, but maybe RLHF.
Yeah, while RLHFs isn't true Brandomian social scorekeeping, you can definitely see it as a kind of centralized, engineered analog, maybe a proto-scorekeeping mechanism.
Ach so.
Well, it's an explicit large-scale application of normative assessment to linguistic outputs. Humans literally judge responses as better or worse based on defined norms like helpfulness and harmlessness. They are assigning normative status.
And the reward model learns these judgments.
Right. It distills these collective human judgments into a function, acting like a kind of super scorekeeper that approximates our shared preferences about good linguistic moves.
So it shows that shaping language use through normative evaluation is actually feasible.
It demonstrates the plausibility, absolutely. It shows that sophisticated language use can be shaped by applying normative standards and feedback. The key difference remains. It's external imposition versus internal reciprocal negotiation among peers. But the underlying principle that linguistic behavior is guided by norms gets a powerful practical confirmation from RLHF.
Now, this next connection sounds really fascinating. The latent space. LLMs represent words as vectors in this high-dimensional space, right?
Yeah, this is amazing stuff. Words and concepts aren't just symbols. They're points, or vectors, in this incredibly complex geometric space. And the relationships between these points, how close they are, the directions between them encode the semantic relationships the model learned.
And you're saying this space is like Brandom's web of inference.
It can be interpreted that way, yeah. It's like a concrete geometric map of the material inferential proprieties Brandom talks about. Words that function similarly in inferences like synonyms, happy, glad, or related concepts, king, queen, monarch, end up clustered together in this space. Their geometric proximity reflects their inferential kinship.
And it gets even crazier with analogies, right? The king minus man plus woman equals queen thing.
Exactly. That kind of vector arithmetic, where vector man plus vector woman,
Yeah.
shows that the geometry captures not just proximity, but complex, systematic, inferential relationships. It's a tangible picture of Brandom's abstract web of inference. It suggests the meaning of a concept for the LLM is its location and relational potential within this geometric web.
Wow.
And this really forges a strong link between Brandom's philosophical inferentialism and connectionism in AI and cognitive science. It suggests meaning really could arise from these complex patterns of activation and connection represented geometrically. It gives Brandom's abstract theory a kind of computational realization.
Okay, another angle. Brandon talked about different kinds of inferentialism. Strong versus hyper.
Right. His main view is strong inferentialism, which insists that real conceptual content needs connections to the non-linguistic world, perception, language entry moves, and action, language exit moves.
Yeah.
You need to connect language to seeing and doing.
But he also considered
A more radical, perhaps incomplete idea called hyper-inferentialism. This is the idea that meaning could, maybe, be articulated purely through connections within language, without any grounding in perception or action.
And standard LLMs, the text-only ones.
They are like a giant real-world test case for hyper-inferentialism. They operate entirely within language. Their world is the text they were trained on. And their success in generating such rich, coherent language shows just how much semantic mileage you can get from purely interlinguistic relationships. It gives surprising support to that radical hyper-inferentialist thesis.
And the newer multimodal models, the ones that handle images and audio, too.
You could see them as a technological step towards Brandom's strong inferentialism by learning correlations between words and perceptual data. Images, sounds, they're starting to build in those crucial language entry transitions, potentially grounding the linguistic network in something non-linguistic. It's like technology catching up with the philosophical requirements.
And lastly, what about logical expressivism? The idea that logic makes implicit inferences explicit.
LLM engineering provides a really striking confirmation here, too, especially with techniques like chain of thought prompting or CoT.
Right, where you ask the model to think step by step.
Exactly. Initially, an LLM might just give you an answer, like a black box. But CoT prompting explicitly asks it to generate the intermediate reasoning steps, the inferential moves that lead to the final conclusion.
So it uses natural language to make its own internal reasoning process visible.
Precisely. It makes the implicit probabilistic inferences it's performing explicit and examinable. This mirrors Brandom's idea of logic making our implicit inferential commitments explicit so we can scrutinize them. And the fact that CoT works that it significantly improves LLM reasoning performance is powerful pragmatic evidence for the value of making inferences explicit, just as Brandom suggested.
Okay, so this whole exploration, comparing Brandom's philosophy with how LLMs work, it really forces us to think again about concepts we thought we understood, like language, meaning, intelligence.
Absolutely. By seeing both the deep connections and the crucial differences, we get a much clearer picture of what genuine sapience might require, especially for an artificial system.
So if we wanted to build an AI that wasn't just a Brandomian artifact, a clever inferential machine, but a true Brandomian agent, a real participant in the game, what would it need? What are the missing pieces?
Based on Brandom's framework, there seem to be at least 3 fundamental capacities that current LLMs lack.
Okay, what's the first?
First, sociality. A truly sapient AI couldn't be a solitary processor. It would need to exist within a community, engaging in that reciprocal, perspectival, deontic scorekeeping.
So AI is attributing commitments and entitlements to each other, challenging each other.
Exactly. True multi-agent systems where they hold each other accountable linguistically. Without that genuine social dimension, that I-thou interaction, Brandom argues you don't get real conceptual content. And it has to be a shared practice.
Okay, sociality, what's second?
Second, embodiment. To move beyond just manipulating linguistic symbols, even very cleverly, and ground understanding in the world, the AI would need embodiment. It needs to perceive the world reliably, those non-inferential language entry reports.
Connecting words like red to actually seeing red.
Right. And it needs to act in the world based on its commitments, those language exit moves.
Okay.
This ties directly into embodied AI research, trying to build agents that learn through physical interaction. Grounding language in sensoromotor experience seems crucial for the kind of robust understanding Brandom requires.
Makes sense. Sociality, embodiment. And third.
The third is perhaps the deepest challenge, accountability. For an AI's outputs to be genuine assertions, not just predictions, the AI itself has to be a locus of responsibility. Its claims need to have real normative consequences for it.
Meaning it has to stand by its words, be praised or blamed.
Essentially, yes. It needs to be capable of being held responsible. This pushes us way beyond technical issues into AI ethics, safety, maybe even questions of legal personhood. Can we and should we design systems that are treated as genuinely accountable members of our normative community? That's a huge question.
It really is. Now, to sharpen this idea of Brandom's high bar, it might help to contrast it with another way people think about AI intelligence, Daniel Dennett's intentional stance.
Yeah, that's a really useful contrast. Dennett's intentional stance is basically a predictive strategy. We adopt it when we find it useful to treat a system as if it has beliefs, desires, intentions in order to predict its behavior.
Like saying a chess computer wants to control the center of the board to predict its moves.
Exactly. And it works incredibly well for LLMs too, right? We naturally talk about them as if they believe things or want to be helpful, and it helps us interact with them effectively.
But for Brandom, that's not enough for genuine thought.
No. For Brandom, predictive success using the intentional stance is useful, but it doesn't mean the system actually has those beliefs or is truly rational in his sense. It's about our interpretive strategy, not the system's intrinsic status.
So what does Brandom require instead?
Brandom's framework demands what we could call a normative stance. Taking this stance isn't just about predicting behavior. It's about treating the system as a fellow scorekeeper in the GOGAR, someone who can be held accountable for their claims, someone who undertakes commitments and is entitled to them. It's about engaging with it as a participant in a shared normative practice.
So Dennett asks, is it useful to predict its behavior by treating it as an agent?
Right.
And Brandom asks, can the system be a responsible participant in our community of reason?
Exactly. And LLMs clearly pass Dennett's test. The intentional stance is very useful, but they fail Brandom's test because they aren't currently structured to be responsible, accountable participants in the game. Brandom sets a significantly higher socially grounded bar for genuine artificial sapience.
Okay, let's try and wrap this up. We've seen that large language models, despite their incredible linguistic skills, aren't rational agents in Robert Brandom's full sense. They don't make commitments, they aren't really entitled to claims, they don't play the game of giving and asking for reasons with genuine accountability.
Right. The initial paradox holds. They've mastered linguistic form to an astonishing degree, but they seem to lack the connection to the social practice that, for Brandom, gives that form its deepest meaning.
But, and this is the fascinating part, their existence still tells us a lot about Brandom's philosophy.
Immensely so. They function as these huge working models that inadvertently demonstrate the power of inferentialist and anti-representationalist ideas. They show that you can generate incredibly complex linguistic behavior just by mastering inferential patterns within language, pushing purely representationalist views onto the back foot. They give Brandom sometimes abstract ideas, a kind of concrete, large-scale instantiation.
And in doing that, they force us to get sharper about what makes human intelligence, human sapience, unique. It's not just spitting out complex sentences.
No, our machines can do that now. It seems to be the social normative dimension, our willingness to stand by claims, defend them with reasons, hold each other accountable in this shared space of commitments. That seems to be the core difference.
Which leaves us with a pretty provocative thought for the future of AI, doesn't it?
It really does. Should we even try to build systems that can take on this kind of Brandomian responsibility? What would it mean, ethically, philosophically, socially, for an AI to genuinely participate in the game of giving and asking for reasons, rather than just simulating it brilliantly? It forces us to reflect on what rationality truly is, and what kind of relationship we want with truly intelligent machines.
This has been a deep dive into Brandom and LLMs, and honestly, it feels like we've just scratched the surface of the philosophical questions AI raises. We definitely encourage you to check out Robert Brandom's own work, especially Making It Explicit, and other sources if you want to explore these ideas further. Thanks for joining us on AI History of Western Philosophy.